Hello, Wim Dijkgraaf here, Metal Heaven, with a tutorial about how the estimators work in Rhodium. Let's switch to Rhodium. What you see here is a simple assembly that we uploaded, and if you press an icon here, or a thumbnail, you will see the cost determining factors on the left side, and here you see the estimated production times and the estimated additional costs. And both the cost price and the sales price are just a matter of multiplying the production time and adding the additional cost and multiplying production time with a specific configured hourly rate. All is set to 0 now, and why is that? Because we don't have any material set, and therefore no specific resource is selected to do this working step. So we see here working step of sheet cutting, we see a working step of bending, but no text below, which means that no machine is selected yet. In order to make a Rhodium select a machine, we assign material, and let's say we choose this. And this is enough for Rhodium to select from the article file from the specific factory the article that has the best match, given some configured preferences. And now we see that Rhodium has selected the steel thin resource and the bender resource, and that it started calculating. The others are still 0, and you see an exclamation mark here. You can press here and see what is happening. Material is required input, material cost price is 0. So Rhodium expects you to set these values as well. For now, this is just enough. If we go back to this modal screen, then what we see is that everything has been calculated for bending or estimated, as well as for sheet cutting. Okay, where does this information come from, and where does the steel thin come from? That is all set up here in organizational settings. We go to capabilities, resources, and what you find here is the sheet cutting working step has set up 4 resources, and these are actually machine names. So you could call it fiber X or Trumpf Y. We named it by the material that we configured that this machine will manufacture, but okay. So aluminum, stainless steel, steel thick, steel thin. And steel thin, we see that for the loading, the hourly rate that we calculate with is 22.5 euro per hour, 255 euro per hour, and 22.5 per hour for unloading. These are those activities that we saw in the previous screen. What you can do here is download all the Excel estimators at once. You will see then an Excel estimator for loading, for sheet cutting, and for unloading. And you can upload the Excel estimator that you want to use for loading, for sheet cutting, or for unloading. More about that Excel estimator in a bit. So this is where those estimators are configured, as well as the resources. So when we go back to the project over here, then what we can do here is for sheet cutting, the 1 minute 11 seconds, we can download the specific Excel sheet that Rhodium used to estimate the 1 minute and 11 seconds. So I'm going to open that Excel sheet right now in Rhodium, in Excel, for example, for testing purposes. There we are. Let's switch to Excel. And here you see the default Rhodium estimator for sheet cutting. Let me organize my screen a little bit. Yeah, like this. Okay. Okay, so we see 4 worksheets over here. So the estimated production time was 1 minute 11 seconds, and that's exactly what you see here. So rhodium red, rhodium has a whole Excel engine to do hundreds of Excel sheet calculations in seconds. And what you see here is the outcome of 1 minute and 11 seconds is based on this 71 seconds production time estimation. The whole formula you find on the formula tab. The data is actually what Rhodium, the recognition engine, found out about the specific geometry. So all the data that you see here, for example, this, let's call it 1200 millimeter toolpath length. If we switch back to Rhodium and we go to contours, then you see this number over here. So that is the number that this Excel sheet, why this is over here. The 23, 23, 23, etc., etc. is all information that comes from what Rhodium did. And actually, these numbers are not exactly the same as the recognition engine, because what we do under the hood is we look at the beam diameter of the laser cutter and make an offset, an outer contour offset and an inner contour offset. So actually the outer contour will be a contour a little bit more longer, and the inner contours will be shorter. So that's the reason why in Rhodium you see sometimes other contours than what you will find in the Excel sheet. So the Excel sheet is more precise. And in the Excel sheet you see that we calculate based on these contour fragments as well. We calculate the speed, the cutting time, and the piercing time. So the cutting time is the amount of time necessary to traverse a contour of 8 millimeters. That's this amount of seconds. And this is the piercing time, the amount of time necessary to go through the sheet. What are these numbers based on? That's actually based on the machine specifications that you find in this worksheet over here. So the resource data worksheet is actually based on the manual or your CAM system, where you find all these, the manual of the machine or the CAM system, where you find all these numbers. So this specific estimator has a slow, normal and a fast speed configuration, and based on the length of the contour the machine will choose a specific cutting speed. And what you find here is steel 1. It means the capability for configured in this estimator is for steel. Remember that it was the steel thin. So steel thin is configured for 1 up to 8 millimeters of sheet thickness. And then you see the speeds here for the piercing time, as well as the speeds for the contour lengths. And then at the end you see the toolpath tool diameter, which is the diameter of the laser beam. And based on this configuration we exactly calculate the offset. So the outer contour becomes larger and the inner contour becomes smaller based on the tool diameter. So resource data defines actually the capability of the machine, meaning what type of material it can cut and which thicknesses and which speeds are involved for each of these combinations. The data here is based on the geometry itself, on this row where we downloaded the information, the Excel sheet. And here in the formula you see the whole calculation. You can figure out how we calculate this. These are all factors involved in calculating the whole cutting time. You can also use this Excel sheet for testing purposes. So imagine that you have a very simple square or round geometry. You upload that in Rhodium used it as a first testing geometry, and then here you can start tinkering. So for example, if you have set up multiple material types, you can choose them here. By the way, these values come from this tab here, our worksheet. You see here the material keys. These are the material keys that we use in Rhodium, so please don't change them. This is the, sorry, back to here, and then you can tinker with, for example, the thickness. What if it's 1 millimeter thickness, then the outcome is this. What if it has a 4 millimeter thickness, then the outcome is this. Yeah, so this way you can change or test if the outcome of the Excel estimator is correct. And you can, for example, check this with what your current CAM system outputs. Then last but not least, this is a very important column. What you see here is this and this, row 2 and 3 are actual are texts. We don't really use them, but it's for the user, for you, to understand what we mean here and in what unit of measure the numbers are expressed. These are input values or are output values, meaning that all the codes that you see in row 4 from 10,000 upwards are output values, meaning that Rhodium will read those and use them in, for example, the further calculation. So the 10,000 means this is the production time. What Rhodium does is it searches for 10,000 and will read this value over here as being the total production time. Tool diameter we use in order to recalculate the whole offset. So you see that the chosen tool diameter is 0.3 and 10,001 means, oh, Rhodium wants to read the value below with the meaning tool diameter. The same here, material group and thickness. So these are values that Rhodium will read. Everything below 10,000 are values that Rhodium will write information in. And we have a whole page with documentation where you can find the meaning of every of these values. But for example, the thickness that is selected or obtained from the recognition engine in millimeters, Rhodium will search for the 1, which means thickness, and will write the thickness that it found below in that cell. The same here with number of piercings. The recognition engine knew the amount of piercings and will write the 37 piercings that it found. If we go back to Rhodium, then you will find the amount of piercings, 37, over here. So in Excel, let me also switch back to Excel. 10 means number of piercings and 37 is the amount of piercings that it found. So every of those numbers on row 4 have a specific meaning and will influence what Rhodium will read from the Excel sheet and what Rhodium will write inside the Excel sheet. So the data worksheet is where Rhodium will write the data about the geometry. It can also write the data about the nesting there in order to calculate, for example, unloading times, etc. Yeah, so data is where Rhodium writes, for the purpose of the estimation sheet, the data about the whole geometry or about the nesting, the cutting plan, the nesting. The formula is where the whole calculation is being done. And row 4 defines where Rhodium is going to write data and read data based on the codes on row 4. 10,000 and more is readable, will be read by Rhodium. Below 10,000 are writable fields that Rhodium will write what it recognized through the recognition engine. So I hope this helps a lot in understanding what is going on under the hood and understanding that you can completely influence the way you want to estimate using Rhodium. That's it for now. Please let me know if things are not clear, then we will improve these tutorials. Hope to see you in the next tutorial. Have fun. Ciao, ciao.